Good morning, students. Today we are going to take a closer look at circles. Last class we have looked at um, formulas for finding areas and perimeters of plane shapes. Okay, where we looked at trapezium, parallelogram, rectangle, circle, square, and the rest. But today we are still going to take a closer look at circles, and we're going to look at what we call an arc of a circle. An arc of a circle. So we want to see how we can find length of an arc, all right, of a circle. Length of an arc of a circle. Now pay attention to that. So what is an arc of a circle? All right, an arc is a fraction, all right, of the circumference of a circle. All right, an arc is a fraction. Sometimes you can say an arc is a part, are you with me, of the circumference of a circle. What is circumference of a circle? It is the distance around a circle. All right, so we have something like this. Okay, so the distance around this circle is what we call circumference. So a part of it may be, something like this from here to here. Are you with me? From here to here. This could be an arc. Let's take this the center of a circle. Okay, this is radius. All right, so from here to here is an arc. From here to here too is an arc. This is a smaller arc. This is a major arc. Are you with me? We call this minor arc. Are you with me? And we call this major arc. Are you with me? Okay, so that is what we call an arc. So the question now becomes, how do we find the length of an arc? You see what I've drawn here? You can assume an angle is subtended here. Okay, an angle is subtended here. So pay attention. We say length of an arc is theta over 360 times 2 pi r. Are you with me? Now theta is angle subtended at the center. Are you with me? By the arc. Pay attention to that. Angle subtended at the center by the arc. R is radius. So that's R is radius. Y pi is a constant, 22 over 7 or 3.142. Okay, so we say length of an arc is theta over 360 times 2 pi r. So I'm going to give an example on it. Okay, the first example says, example 1. Are you with me? An arc, all right, of a circle with radius 14 centimeters subtends an angle of 135 degrees. Oh, sorry about this. An angle of 135 degrees. All right. Calculate the length of the arc. Is that clear? An arc of a circle with radius 14 centimeters, subtends an angle of 135 degrees. Calculate the length of the arc. All right, so you've seen the question. Now let's try to solve the question. Okay, let's try to solve the question. So solution, length of the arc equals to theta over 360 times 2 pi r. 2 pi r. Is that clear? So our angle now is 135 degrees over 360. All right. Times 2. What's our pi? 22 over 7. What's our radius? 14 centimeters. Okay. So how can we do that? 7 here, 1, 7 in 14, 2. Okay. Okay, 135 over 360 will give us 0.375 times 2 times 22, 44. 44 times 2 is 88. All right, centimeters. So we're going to have something like this, 33 centimeters. So that's that about that. That's that about that. So let's take another one. Okay, another example. All right, given that, all right, given that the radius of a circle is 28 centimeters and the length of an arc is 44 centimeters. Calculate the angle subtended at the center. Pi is 22/7. Are you with me? Given that the radius of a circle is 28 centimeters and the length of an arc is 44 centimeters, calculate the angle subtended at the center. Is that clear? So we have something like this. All right. Solution. We're looking for theta, which is the angle. All right. We have length is 44 centimeters. Radius is 28 centimeters. All right. Is that clear? So remember formula, length equals to theta over 360 times 2 pi r. So we say 44 equals to theta over 360 times 2 times 22/7 times our radius is 28 centimeters. All right, so we can have something like this. 7 year 1, 7 and 28 is 4. Okay, and then we have 44 equals to 2 times 22, 44, 44 times 4. Okay, so we can have 44 theta times 44 times 4 over 360. Are you with me? Is that clear? All right, so over 1. Then we can cross multiply. All right, we can cross multiply. Let me use here so that you can still follow me with the teaching. Okay, over 44. So we can have theta times 44 times 4 equals to 44 times 360. Remember, we cross multiply. All right, so we can divide both sides by 44 times 4. 44 times 4, because we are looking for theta. This cancels this. We have theta equals to 44. We cancel 44 here. 4 here 1, 4 in 360 is what? Talk to me. 4 in 360 is what? 90. So theta is 90 degrees. Is that clear? Is that clear? Okay, so I'll give you one more last example and then we can call it a day now. So we have something like this. All right. Example. All right. Given that the length of an arc is 90 centimeters, the angle subtended at the center of the circle is 240 degrees. Calculate the radius of the circle. Okay? Calculate the radius of the circle. All right. So, solution. We have L equals to theta over 360 times 2 pi r. All right. So we have now our L now is 90 centimeter equals to theta, which is 240. Okay. Rather, we have 240 over 360 times 2 times 22/7 times r. Okay. We don't know r. R is what we are looking for now. Is that clear? Okay, so we can say 90 equals to 240 times 2 times 2, and 2 is 44 times r over 360 times 7. Okay, so if we cross multiply, 240 times 44 times r equals to 90 times 360 times 7. So our r equals to 90 times 360 times 7 over 240, pay attention to that, times 44. Is that clear? So if we simplify, r would be equals to 21.5 centimeter. That's to 1 decimal place. Is that clear? All right, so I'm going to give you some questions for classwork. I want you to do it and you can send it back to me. Thank you. Have a beautiful day.